Welcome back to chapter 5. We are going to focus on algebraic term and coefficient today. Let's do some revision of last week. Last week we learned how to write an algebraic expression. So first we have a story. For example, here in a class, and there are stories here. You understand the story, and from the story you create an algebraic expression. So this is the algebraic expression you have created. There are numbers, and there are also variables inside. So all these are called an algebraic expression. Second part, determine the value. With this algebraic expression, if my variable such as x is given and y is given, I can put the numbers in here. Therefore, I'm able to solve this equation and I'll be able to get the final value here. So this is what we call determine the value. As for today, we're going to learn what is algebraic term. This is a new name for you, term, and what is coefficient in the algebraic expression. So first, let's identify the number and value or variable in this algebraic expression. As we know, algebraic expression means 2x plus 3xy. So what is the number here? Number means 2 and 3. And last lesson we have learned what is called a variable value, 变数, or we can also call it as variable. So for a 变数or a variable which is changing and we do not know, we always represent with alphabet. Therefore, x and y, they are called variable value or variable. Hi, welcome to the new things that we are learning today, called algebraic term. In this algebraic expression, read together with me first. M squared plus 2x plus 3xy minus 6. So first tell me, what are numbers here? 2 is a number, 3 is a number, 6 is a number. Be very careful, 2 here is not a number. This is called a square. Next, what are the variables here? Variables are always represented by alphabet, 字母. Variable is something that we do not know yet. So m is a variable, x is a variable, and y is also a variable. So now, what is algebraic term? In the algebraic expression, we try to find plus and we try to find minus, and we draw an invisible line here. So the algebraic term are number or variable that between the plus and the minus. So m squared is an algebraic term. 2x is also an algebraic term. 3xy is one algebraic term, and 6 is also an algebraic term. So I can write my algebraic term are m squared, comma, 2x, comma, 3xy, comma, 6. So how many algebraic terms are there? So this is called 1, 2, 3, 4. So I have 4 algebraic terms in this algebraic expression. So take note, if you have a variable m here, and m is square, that means you have m times m. This is also considered as a term, including the square itself. These are also considered as a term because it is separated by the plus. And next, if you see a number here, it is also considered as a term. Why? Because it could be multiplied by m to the power of 0, which is equals to 6 times m to the power of 0. Any alphabet to the power of 0 is 1. So it's 6. So it is also considered as a term. Let's do some exercises together with me. Here I have an algebraic expression. Read together with me. X plus 5x. So what are the numbers here? 5 is my number. And what is the variable here? I have x is my variable here. Same, x. So identify the algebraic term. First, find the operation plus and the minus. Separate them. And x is an algebraic term. This one is another one. So my algebraic term are x, 5x. How many of them altogether? 1, 2. So there are 2 algebraic terms in this algebraic expression. Next, pq minus 2q plus 13. Identify where is my minus and where is my plus. So, very clearly I can see there are how many terms altogether? 1, 2, 3. So algebraic terms are pq, 2q, and 13. So I can write them as algebraic term are pq, 2q, 13. How many algebraic terms altogether in this algebraic expression? There are 1, 2, 3. 3 altogether. This is an algebraic expression of x divided by 8 minus 7y. So how can I identify my algebraic term? Find plus and minus. So these are minus. I draw a line here, separate between these two. So on my left there is one term, on my right there is one more term. So my algebraic term are x of 8 and 7y. X of 8, 7y. How many of them altogether? There are 1 and there are 2. So 2. So with this, I would like you to try out practice makes perfect question number 1. Identify all the terms. Here is a reminder for all of you. We have this m square in chapter 3. We learned that m square equals to m times m. And m cubed, we learn it as equals to m times m times m. M square, we can also read it as m square or m to the power of 2. So here is the power for m. This is what we call power. So this is m square, also read it as m to the power of 2. This is what we call m cubed, also read it as m to the power of 3. Now, how about this? M to the power of 1. M to the power of 1 is also m times 1 time only. It's called m to the power of 1. How about m to the power of 0? Any number or any variable to the power of 0 is equals to 1. Keep this in mind. Second part, like terms and unlike terms. Like term means 同类的. Unlike means 不同类的. Look at this table. How can we consider it as unlike and like? So on my left, they are called like terms. How? First, in this term and this term, they must have the same variable. Yes? Variable of m appears here. Variable of m also appears here. Second, m variable must have the same power, m to the power of 1 and m to the power of 1. So I can say that negative 2m and 3 of 7m, they are both like terms. 它们两个是同类的. Look at the second example. Check for my variables. Oh, I have p and I have q. Oh, p and q, exactly the same. P to the power of 1, p to the power of 1. 1, 1. Yeah, same variable, same power. So I can say these and these are like term. Next, oh, I have A, B. I also have A, B here. Although they are not in the same sequence, but A appears for one, A appears for one. B appears for one time, B here also appear as one time. So I can say that, yes, they are having the same variable. Check for the power. Oh, power 1, power 1, power 1, power 1. So I can say 6AB and 7BA, they are like terms. Likes. Oh, K square, K square. First, check for the variable. K, yes, K. Check for the power. Power of 2, power of 2. So I can say 5K square and negative K square, they are both like terms. You might be asking, teacher, there is negative here. Don't forget, negative K square, if you break up, it will be negative 1 multiplied by K square. So if I'm going to compare only variable, this is K, this is K. Power of 2, power of 2. So negative belongs to the negative 1 here. So we are not going to compare about the number. We only look at the variables. Same variables, sequence doesn't matter. Same power, they are considered as like term. Next, unlike terms, 不同类的. Again, we are comparing variables. If the variables are not the same, for example, the first one, I have V here, but there is no V here. I have W here, but there is no W here. So 2V and 2W, they are unlike term. Check for the second one. I have X here, but there is no X here. Yes, there's Y, there's Y. There's Z here, but there is no Z here. So I can say that 5xy and negative yz, they are unlike term. Besides comparing the variables, we also compare the power. Oh, I have variable the same. I have x and I have x. Second step, look at the variable, power. Oh, x squared here, x to the power of 2. X here, there is no power. So there is no power means x to the power of 1. 1 here, 2 here, they are not the same. So I can say 9x squared and 8x, they are unlike term. Last one. This looks very complicated. Let's check for variables first. Variable m, variable n. Variable m, variable n. Oh, looks like, yeah, they can be considered as like term. But check for the power. M to the power of 2. M to the power of 1 here. N to the power of 1. N to the power of 2 here. No, they are not the same. So 3m squared n and 1 of 4 mn squared, they are unlike term. Are you clear now with this? Check for variables. Check for power. Right, let's do some exercises together. Which pair is like term and unlike term? Like terms 同类的 unlike term 不同类的 Like terms, we are comparing two things, variables and the power. If both are the same, so we call it as like terms. If variables not the same, or if the power is not the same, so they are considered as unlike terms. Let's check for the first one. X, y, and I have x, y here. Check for the power. X to the power of 1, x to the power of 1. X to the power of 1, x to the power of 1. Exactly. So they are, think about it. I have P here. P here. I have Q here. There's no Q here. So you know the answer. I have A here. I have A here. I have B here. I have B here. I have C here. I have C here. Oh, all pass. Check for the second. Power 1, power 1. Power 1, power 1. Power 1, power 1. Wow, all correct. All the same. So they are. Last one. Check for the variable. H here, H here. Check for the power. 1 here, 2 here. No, no. So what are the answers? Do you get it correct? xy, xy. Power of 1, all the same, like terms. Unlike y. Q here, there's no Q. R here, there's no R. Unlike. Check for the third one. ABC, BCA. All variables are there. All the powers? 1, 1, 1, 1, 1, 1. So they are like terms. And the last one. Variables the same, but the power are not the same. Unlike terms. Here you go. This is a practice makes perfect. Question number 2. Write down both of these and tell me, is this a pair of like term? If yes, write like term. And if it's not, write unlike term. Here is the part 3, factor and coefficient. Let's recall on chapter 2, factor. Tell me the factors of number 8. So factors are two numbers that multiply together can get 8. So 1 times 8 equals to 8. So 1 and 8, they are both factors of 8. Any other things else? Yes, 2 times 4 are also factors of 8. So I can say that 1, 2, 4, 8, they are the factors of 8. So now, we are moving up level from a number. We have algebraic term now. So 3xy, besides number 3, I also have variable of x and y. Now, tell me the factors of 3xy. Always start from the very basic. 1 times what equals to 3xy? Yes, 1 times 3xy equals to 3xy. So 1 and 3xy, they are both a factor of 3xy. What else? Oh, I can also take 3 out. 3 times what equals to 3xy? 3 times xy equals to 3xy. And next, besides taking out number, I can also take out variable, for example, x. If I take out x, I'm left with y3. So x times 3y equals to 3xy. These are also the factors of 3xy. Besides taking out x, I can take out y too. When I take out y, I'm left with 3x. So 3x and y, they are my factors. So the factors of algebraic term 3xy are 1, 3xy, 3, xy, x, 3y, y, 3x. All them are the factors of 3xy. I'm going to link the chapter 2 factor with the chapter 5 coefficient. Listen carefully. As you know, here I have one algebraic term, 3xy, and all this surrounded 3xy, they are the factors of 3xy. So now, I'm going to tell you what is coefficient. Have a look at this table. So my algebraic term is 3xy. And the factors I list down here, they could be x, could be y, could be xy. And the factor here can also be called as variable because they are all variable. So what is coefficient here? Coefficient means in this algebraic term, if I take out my factor x, what is left is 3y. So we call this as coefficient. Again, if I have a term algebraic called 3xy, and my factor I take out my y, therefore I cancel off my y, what is left here is 3x. So 3x is my coefficient. Again, for algebraic term 3xy, if I'm going to take out my factor or variable 3xy, so what is left is 3. So for any algebraic term, if I'm going to take out my variable or factor, I need to cancel them off, and then what is left are called coefficient for the algebraic term. Let's do one example together. I have one algebraic term here called negative 3k squared mn. So if let's say I'm going to take out my variable m, I cancel off m here. So my coefficient is, what is left? My coefficient is negative 3k squared n. Similarly, let's try out if my variable n is taken out. What is my coefficient for this algebraic term? If my n is taken out, so negative 3k squared still there, m is still there, n is cancelled off. So this will be my coefficient. Next, let's do this. If my negative 3mnk is taken out, what is left? Oh, negative 3 is cancelled, m is cancelled, n is cancelled, k, 1k is cancelled. So 1k is cancelled. I'm left with what? Let's explore together. K squared means k times k. So if I take out 1k here, that means a slash of 1k, the coefficient are left with only k. Is that clear? So for an algebraic term, if I take out my variable, I just cancel the variable off. What is left, 剩下的, is coefficient. So question 3, copy down the table and the algebraic term here, negative 3k squared mn, and put down all the coefficient for all the variables here. For question 4, please state the possible coefficients for the algebraic term. So now, you have one algebraic term here, which is negative 10 ABC. There are 4 columns here, 1, 2, 3, 4. Coefficient and variables are blank. So you are free to fill in the pair of variable and coefficient. So if you choose the variable of A, so what is left are called coefficient. You can also choose AB, or you can also choose ABC, or you can also choose negative A or negative B. Up to you. So we'll discuss this in the class. Also continue with question 5 and 6 according to your groups. See you in the class.